Linked list cycle. Given head, the head of linked list determine if the linked list have a cycle in it. There is a cycle in the linked list if there is some node in the list that can reach again by continuously following the next pointer. Internally, position is used to denote the index of node that tells next pointer connect to. Note that the position is not passive parameter. Return true if there is a cycle in the linked list, otherwise return false. Okay, for example, we have a linked list 320 -4, and then after -4 is point back to 2. So in that case, it will form a cycle, and since there is a cycle, we will return true. Another example, we have 1, 2, and 2 point back to 1, so there's a cycle, so we return true. This last example, if there is just one node in the linked list, that means it will impossible to have a cycle, therefore we return false. So for this question, I'm gonna use iterative approach, and I'm gonna use 2 pointer. I'm gonna have a pointer that move 1 node at a time, and then another pointer move 2 nodes at a time. And then if they met when they traverse the linked list at some point, that means the linked list have a cycle. Otherwise, if the fast pointer reach the end of the linked list, that means there's no cycle. So let's implement the code. First, I will have a list node called slow. I will point to the head, and then I have another one called fast. Also point to the head, and then I will have a while loop, and inside of while loop, so the terminate condition for the while loop is when the fast pointer reach the end. So to know when it's reached the end, we can check if fast is not now, then we continue. If it's now, then we break because we know it's reached the end. But since we move fast pointer 2 nodes at a time, we can also have the other condition when we add the second to the last node, and then when the linked lists don't have a cycle, the fast.next is not now, but fast.next.next will be now. And then in that case, we also want to check, so we want to make sure fast.next, if it's not equal to now, then we continue. If it's fast.next is equal to now, then that means we reach the end also. So since we don't want to have a non-pointer exception, this is how we handle that. So in the while loop, I will say slow equal to slow.next, which move 1 pointer at a time, and fast equal to fast.next.next. And then I will check if at some point slow equal to fast, that means there is a cycle, so we return true. And then if we break the while loop, that means we reach the end, so we return false. And then let's also include some edge cases check. So if the head is equal to now, that means that the linked list don't exist. So, or when head.next equal to now, that means the linked list only have one node. In both cases, we just return false because empty linked list and only one node linked list cannot form a cycle. And before let's maybe work through the code. So for example, when we add so let's give 2 examples. Let's say we have 1, 2, 3, 4, 5. So and then 5 point to now. So first we will have fast go 1 to 3 to 5, and then 5 the next is now. So we don't want to enter the while loop, because if you enter it, it will check next or next. It will have non-pointer exception. So in this case we return false. If we have 1, 2, 3, 4 now, then we will have 1, 2, 3 to now, and then this will also be detected. In that case, we also return false because we know we reached the end. And then for the other cases, if they meet, we know there's a cycle. And the time complexity for this is O of n. Even though we could keep even the worst cases is when after they make a few iterations in the circle. So maybe it will be 2n or 3n, but because we will drop the constant, so it will eventually be n. And the space complexity will be O of 1 because we didn't create any data structure. We just create a few nodes, which is constant. So next, let's test this out. Oh, I forgot the semicolon. Looks like we passed the test.